Welcome to this explainer. Today, we're exploring one of the most profound technological shifts in modern cryptography. We're going to dive deep into the fascinating world of zero-knowledge proofs, guided by Charles Hoskinson's comprehensive book, Proving Nothing. Now, if you've been following the evolution of digital privacy and blockchain architecture at all, you know this isn't just about hiding data. No, it's about fundamentally rewiring how we establish truth online. Okay, let's dive right into this. Arthur C. Clarke famously said that advanced technology is indistinguishable from magic. And honestly, when you first encounter a zero-knowledge or ZK proof, it really does feel exactly like a magic trick. But as our source material points out, it's actually way more astonishing than magic. Because think about it, magic relies on deception, right? It relies on hiding the mechanism from you. A zero-knowledge proof, on the other hand, hides the secret data, but it lets you completely verify that the mechanism itself is totally honest. To really wrap our heads around this, let's look at a brilliant metaphor used throughout the source text. Imagine a massive stage. The person generating the proof, the prover, well, they're basically a magician performing a trick backstage. They have some highly secret information. Now you, the audience sitting out in the theater, you represent the verifier on a blockchain. The zero-knowledge proof allows you to receive this sealed, mathematically guaranteed certificate that the trick was performed flawlessly, exactly to the rules, without the magician ever having to reveal the messy, secret reality of what's backstage. Here is our roadmap for today. We'll be hitting the art of ZK proofs, how they're applied on blockchains, what the Midnight Network actually is, its security architecture, the core benefits of the network, and finally, what a trust-minimized future looks like. Section 1. The Art of ZK Proofs. Let's completely demystify how this mathematical magic actually operates in reality. So, the traditional way our society operates is through something called monolithic trust. Think about it. You literally hand over your entire financial history to a lender or your most sensitive medical records to an insurer. You are giving them a massive, complete dossier of your private data just to prove a single tiny fact, like whether you qualify for a loan. Zero-knowledge proofs completely flip the script here. They don't magically eliminate trust entirely. Instead, they decompose it. They take a single, massive act of faith and turn it into a series of simulatable, verifiable mathematical steps. You essentially send the verifying bit, a rock-solid proof that you qualify without ever having to hand over the private dossier. Section 2. Blockchain Applications. So how is this trick currently being deployed? Let's shift our focus to the grand stage of public blockchains. Right now, there are 3 primary stages where this technology is just absolutely shining. First up, we've got ZK rollups. These use proofs to scale blockchains by executing thousands of transactions off-chain, and then they just post one tiny verified proof back to the main network. Super efficient. Second, we have ZK coprocessors, which lets smart contracts do some really heavy historical data computation off-chain securely. And third, ZK identity. This is huge. It allows everyday users to selectively prove things, like say your age or your compliance status, without exposing your actual personal identification. Now, what's really interesting about this slide is what's actually happening to trust across these systems. Notice that trust isn't just disappearing into thin air, it's being relocated. In rollups, we move our trust from human validators over to a mathematical proof system. In coprocessors, we pivot from trusting centralized oracles to trusting pure, undeniable math. And in identity, we stop trusting a random stranger at a bar with our physical ID, and instead we trust the cryptographic proof. We are literally moving trust away from fallible human institutions and placing it squarely into the hands of verifiable mathematics. Section 3. What is the Midnight Network? Let's introduce Midnight, which is kind of the ultimate realization of this privacy theater metaphor. If you look at standard Layer 1 blockchains, like Ethereum rollups, for example, ZK is essentially just used as a data compression tool. It's a bolt-on optimization to make things run a bit faster and cheaper. But Midnight is fundamentally different. On Midnight, the zero-knowledge trick is the entire show. Our source text literally refers to this as the privacy theater. Here, every single state transition, every single smart contract executes via zero-knowledge proofs. It's not some afterthought. It is the core execution model of the entire ecosystem. Section 4. Midnight's Security Architecture. Let's pop the hood on Midnight's architecture and see exactly how it manufactures these sealed cryptographic certificates. The life of a private transaction on Midnight follows a highly structured 4-phase pipeline. Step 1. The application executes locally right on the user's machine, creating an unproven transaction. Step 2, a local proof server running directly on that user's device actually generates the heavy cryptographic proof. Step 3, this newly sealed proof is finally submitted to the network. And step 4, the blockchain verifies the proof in mere milliseconds. But here's the absolute kicker. Notice that the sensitive data literally never leaves step 2. The magic happens entirely locally, and only that mathematically sealed certificate ever gets broadcasted to the world. Now, you might be wondering, what's the catch? Well, the biggest vulnerability in these systems usually isn't the insanely complex math failing. It's just human software engineering errors. Midnight solves this beautifully with a specialized language called Compact. Its compiler acts as this massive permanent guardrail. It enforces a strict rule where data values are kept private by default. If a developer accidentally writes code that tries to leak a private variable out to the public chain, the compiler literally throws an error and stops it before the program is even built. It forces privacy by design, which is absolutely crucial. Section 5, the benefits of the Midnight Network. We've talked a lot about the technical plumbing, but let's pivot to why this actually matters to everyday users and developers. This visual perfectly illustrates Midnight's structural elegance, the 3-token architecture. Instead of cramming every single network function into one coin, which gets messy, Midnight cleanly separates them. You have Bari for network governance, Dust for paying your transaction fees, and Night for unshielded utility. This is so smart because it cleanly separates the economic cost of using the network from the power to actually govern the network. It protects the whole system from wild attacks, like flash loans, where someone might try to just buy up temporary voting power. So all of this architecture builds into some massive real-world benefits. First off, Midnight delivers truly programmable secrets. It allows for highly secure updates to the ledger without ever exposing the underlying data. And for developers, it's a game changer. It seamlessly unifies standard, comfortable TypeScript-like coding with insanely complex ZK circuits. In short, it empowers developers to build applications where they can confidently send that verifying bit to the blockchain without ever risking handing over the user's private dossier. Section 6, a trust-minimized future. As we wrap up this explainer, let's zoom out and look at the massive philosophical shift this technology represents for our digital society. You'll hear the word trustless thrown around constantly in the crypto space, while the source material makes a highly compelling argument that trustless is actually a flawed marketing myth. Honestly, we're never truly without trust. We still have to trust the software compilers, the physical hardware, the core mathematical assumptions. But what zero-knowledge proofs do give us is a brilliantly trust-minimized world. It takes one giant point of failure, like trusting a single bank with all your personal data, and distributes that risk across multiple, highly auditable mathematical points of failure. We are crossing the threshold into an era where telling the truth is actually easier than lying. An era where proving a hard fact doesn't require surrendering the context that makes it private in the first place. The magician performs backstage, the audience verifies from the seats, and the mathematics ensure that the proof reveals nothing but the absolute truth. So, to wrap this all up, here is the ultimate question for us to ponder. In a world of programmable secrets, where you finally have absolute control over your own data, what will you choose to reveal?